The first thing in this actually is not potential, but it is potential difference, right? This potential difference has the potential energy difference in Earth's gravitational field. Defined as the work done on an object of mass m, there, mgh it is. On an object of mass m against the gravitational field force. To take it from a height h1 to h2. Because it is the work done against the gravitational field force, which is mg bar. Work done against the gravitational field force, which is mg bar, we define this potential difference as what? Minus mg bar dot dl bar universally. General case it is. Minus mg bar dot dl bar will give you the positive potential difference if you are indeed working against the gravitational field force and taking it up in the field. Because it is against, work done against the field force, it is minus. In the same way, between 2 points, whenever it is the difference, A and B, in the electric field, described by giving electric field intensity at any point. Okay, electric field is the work done on a small positive test charge on a small positive test charge against the field force per unit of the charge. In moving it from A to B. Check it once. Is the work done on a small positive test charge against the field force per unit of the charge in moving it from A to B. So, if E bar is the electric field intensity, at any point in the field, the potential difference VAB is equal to sorry, VBA, because we moved it from A to B, initial position. So VBA equal to minus integral point A to B. E bar dot dl bar is what we discussed yesterday. If E bar is the electric field intensity at any point in the field, the potential difference VB with respect to A. We know in electronic circuits, we do talk about VCE. When emitter is connected to ground, basically, VCE is the potential difference between collector and emitter. We give the supply to C, and E is common point. So VCE, VC minus VE it is actually. VGS is potential of the gate terminal with respect to the source terminal. VBA as such will give me, later on we will see that, is VB minus VA, where VB and VA are the potentials at the points A and B, or B and A respectively. VBA is equal to minus integral A to B E bar dot dl bar. In fact, one more thing. That is what is at any point. At any point in the field, carefully see this. If a unit positive charge, right? For the sake of talking about it, if a unit positive charge is moved through a differential vector dl bar, the potential difference between the final and initial points dV, change in potential, is equal to minus E bar dot dl bar. From A to B, if you move, total potential difference is minus integral E bar dot dl bar. To be remembered for the sake of gradient of potential later on. dV is equal to minus E bar dot dl bar. Given E bar at any point is equal to EX plus EY plus EZ, where EX, EY, EZ are general functions of X, Y, Z, are constants, doesn't matter for us. EX, EY, EZ are the components. The potential difference VBA is equal to minus integral A to B EXAX EYAY plus EZAZ dot dl bar is what? DXAX plus DYAY plus dz, which is equal to A to B. I'm giving the example in Cartesian coordinate system. Right, we should be in a position to answer it in any coordinate system, of course, right? Ex dx plus ey dy plus ez dz. Listen carefully. At any point, minus ex dx gives me what? At any point, minus ex dx gives me the work done against Ex in moving it through a distance dx. Definitely dl bar is dxax plus dyay plus dzaz. When I talk about dot product, dx comes only with ex, dy comes only with ey, right? Ex dx is the work done. I moved it through dl bar. Along x-axis, distance between these 2 points is dx. At any point along the path in which we are basically taking the charge, ex dx is the differential amount of work done minus, along with minus, against ex, moving it through a distance dx. Ey dy is the work done on the unit positive charge minus ey dy. In moving it through a distance dy against dy. Similarly, minus ez dz is the work done in moving unit positive charge through a distance dz against ez. Work done against x-axis with minus sign. Work done against y-axis, y field. Work done against z component of the field. X component, y component. Total work done we are doing. Listen carefully. When the charge is taken, moved actually, along a path given by the curve is, in general, y is equal to f of x and z is equal to g of x. This is what is the curve. Along a line or a curve, only one of these 3 variables is independent variable. The other 2 are dependent. What to do? Y and z in ex, ey and ez are replaced with f of x and g of x respectively. Mathematics it is. Number 1. Number 2. dy is replaced with, because only one, we are considering x as the independent variable. Dy is replaced with dy by dou y by dou x is equal to f dash of x, or dy by dx is equal to f dash of x. because it is only f of x. dy is equal to d by dx of f of x into dx. Check it once. F dash of x into dx. dz is replaced with g of x into dx. Ultimately, in the integral, we see only x as the variable integrated with respect to x only, because we will be replacing dy and dz with functions of x and dx. So, and the integral is evaluated as minus integral x is equal to x1 corresponding to x coordinate of a, x is equal to x2 corresponding to x coordinate of b. Please check, I will explain it if it is required. And once again, of ex plus ey times f dash of x plus ez times g dash of x times dx. Because there are cases where we will be asked to define whether the field is, determine whether the field is conservative or not. If the field is conservative, the potential difference between the points A and B, defined in this as VBA, should be independent of the path followed. When we evaluate the integral, we should ensure that we are following the specified path only, because of which we write this integral. Please check it once. Having defined the potential difference as minus of integral initial coordinate to final coordinate, initial point to final point along the given path, E bar dot dl bar, I would have taken some point as initial point, some other point as the final point. If I move it from initial point to final point, if we are indeed moving in the direction opposite to the field force, if we are moving in the direction opposite to the field force while going from initial point to final point, this integral minus integral E bar dot dl bar should return a positive value. In the opposite case, where I'm moving from A to B, we are talking about VBA only, VB with respect to VA. If you are moving in the direction of the field is doing the work, because of which the integral should return the negative value. VBA need not be always positive. It can be negative also, we know that. In the case of PNP transistor, circuit with PNP transistor, to the collector we'll give negative supply. We call it as VCA. In the case of NPN transistor, the collector sub voltage is VCA only. For a PNP transistor, collector voltage is negative with respect to ground. For an NPN transistor, collector voltage is positive with respect to ground. In both cases, VCA is basically it is called as VCA only. When you give the value, that value is negative value for PNP, and for NPN it is positive value. So you should remember that. When you say VBA, defined it as against, but when 2 points are taken, we might not have moved against, or along a part of the path we are moving against and then towards in the direction of the field, or vice versa. Ultimately, if you have moved against the field force, net work done will be positive, telling that the potential difference is positive. Just for the sake of introducing it to you. Given E bar is equal to everywhere 2AX. I will take along x-axis. I will say this is -1. This is 1. This is 2. This is 3. Don't worry about the distances I marked. Okay. -1. When it is moved along x-axis or along a straight line parallel to x-axis, this is x-axis. As long as the path is along x-axis, DL bar is dxax. You're trying to concentrate, right? Please concentrate properly here. DL bar is dxax. I will say this is A, this is B. In one more case, I will say this is A, this is B. For the sake of talking about it. What is VA? VBA? VBA is equal to integral -1 to 1. Correct only? Because I'm going from A to B. E bar dot DL bar is what? E bar dot DL bar is 2dx minus E bar dot DL bar now. Which comes out to be? What is the value of this integral? -4 volts. Joule per coulomb is volt. Here also, I should say that it is so many volts. Yeah, we need to talk about the unit also. Correct? -4 volts. In this case, it is next case. Integral 3 to 1 E bar dot DL bar minus is what? Minus E bar dot DL bar is again 2dx. Please check it. E bar dot DL bar is not depending upon whether we are moving to the right or left. It is universally DL bar is dxax along this. In general, in the space, it is dxax plus dyay plus dzaz. Don't look at whether I'm moving to the right or left in along x-axis, right? The direction in which you are moving is basically given in the interval limits. Initial point coordinate corresponding to the initial point to the terminal point. What is this value now? 4 volts. If you look at it, everywhere E bar is to the right. E bar is to the right because it is 2ax. In the first integral, it is moved from A to B. Means what? We are not moving it. Field only is moving it. We need not move. We need to do the work if I want to move it from A to B because I'm working against the field force. When the work is done against the field force, minus E bar dot dl bar returns positive value. Otherwise, if it is moved in the direction of the field force by the field only, E bar dot dl bar minus will return a negative value. Now listen. I will take a case. E bar is equal to 2x ax plus 3y ay in xy plane, or z is equal to constant plane we are there in. Or I'll say in general it is 5z az. Just like that I took. So many volt per meter electric field intensity. So many volt per meter. I will show you the path. This is x-axis. This is origin. This is y-axis. One path is, sorry, A and B are these points, right? This is point A with coordinates 2, 0. This is point B with coordinates, let us say 0, 3. I can actually define one path as this. A to B. Carefully look at it. Or it can be this path also. Come to origin. Go to this. Path 2. I can define many such curves. On, I'll even do this. For complicating it in the first level itself. 4 means what? It is z is equal to 4 plane on which x and y only can change. On this z is equal to 4 plane, this is path 1. This is path 2. Consists of 2 straight line paths. I want to calculate VBA. To calculate VBA, please remember now, concentrate. For the path 1, what is DL bar? Because it is some line in XY plane. DL bar is dxax plus dyay. Because We are there on xy plane. And what is the line equation? And the line equation is x by 2 is equal to y minus 3 by minus 3, correct? Or x is equal to, y is equal to 3 by 2 x minus plus 3, na? Check it. Is it correct? X minus x1, some value. So x2 minus x1 is equal to y minus y1 by y2 minus y1. I think now it is done, right? Y is equal to 3 plus 3 by 2x. Three minus 3 by 2x. Y is equal to 3 minus 3 by 2x. Line integral is there, because of which I am doing this. Anyway, we have to do many, right? When you go to gradient of potential and all. 3 minus 3 by 2x, correct only. X is equal to 0, y is equal to 3. X is equal to 2, y is equal to 0. It's a straight line. Slope of it is minus 3 by 2, dy by dx. VBA is equal to what? For the first path, VBA is equal to minus integral. Tell me. E bar dot dl bar is equal to minus integral 2x dx plus 3y dy, 2x dx plus 3y dy. dz is not there, not possible in this. Z component will not come into picture here, because it is normal to the plane in which we are taking these parts. Now, if I should know, this can be evaluated in two different ways. One is what? Taking x as independent variable. This is equal to x is equal to 2 to 0 minus of 2x dx plus 3y is what? 3 into 3 minus 3 by 2x. Because it is 3y. dy is equal to what? Minus 3 by 2 dx. This is f of x. Y is equal to f of x. dy by dx is equal to f dash of x, right? dy by dx is equal to minus 3 by 2, because of which minus 3 by 2 is called as what? F dash of x. dy is equal to minus 3 by 2 dx. Ensuring that we are going along that path only. At each and every point, x and y are related. For a given x, y is fixed. For a given dy, dx is fixed. Check it once. What is this integral now? Minus integral 2 to 0. Together, what is the function to be integrated? 2x minus 9 by 2x minus 5 by 2x into minus 3 by 2. Correct only, no? Please tell me the expression inside the integral now. Can somebody tell? with minus outside, it is 2x minus
9 by 2.
9 by into minus 3 by 2, right? 2x minus 27 by 4. 2x plus 27 by 4. Correct? 2x plus 27 by 4 x. Correct, only?
Minus 27 by 2. The
Constant
next
terms.
terms.
Minus 27 by 4.
2.
Yeah, 27 by 2. Minus 27 by 2. Or it is 2x 8. 35. 35 by 4x. Minus 27 by 2 dx equal to finally what? 35 by 4 x square by 2 minus 27 by 2 x from 0 to 2. Why? Because that minus got absorbed now, right? Because of which it is 70, correct? 70 na? 4 by 2. 35 by 2. So, correct, you know? 35 by 2 is 17.5 minus 27, which is minus 9.5 volts. Minus 9.5 volts. No, let us know, try to understand why it is coming out to be minus. Effectively, with x component is equal to 2x. Please see in the figure. I effectively moved in opposition to 2x only through 2 units. But in the direction of 3y, which is increasing as with y, in the direction of 3y, we moved through 3 units. The work done against the x component by us is less than the work done by the field along y-axis. Because more work is done along y-axis by the field, minus 27, and lesser work is done against the x component of the field. The overall potential difference is negative. Check it. For the path 1. For path 2, it is integral minus 2x dx plus 3y dy along y is equal to 0 line from x is equal to 2 to 0. Correct only? In fact, this is not there for us. minus integral 2 to 0 again. 2x dx plus 3y dy along x is equal to 0 line. Correct? Initial part of this is y is equal to 0 line because it is x-axis. This is because it is y-axis, x is equal to 0, because of which there will be no dx. Along first path, there is no dy because it is y is equal to constant line. But on the next part of the second path, along y-axis, x is equal to 0 it is, because of which dx is equal to 0. This is telling me what? Minus integral 2 to 0 2x dx minus integral now y is equal to 0 to 3. Here y is equal to 0 to 3. X is equal to 0 line it is. Y is equal to 0 to 3. Right? 0 to 3. 3y dy. Which is equal to what? Minus x squared from 2 to 0 minus
Y cube.
y cubed.
Sorry, y square.
3 by 2 y squared from 0 to 3. What is the value?
Answer is minus 0.5.
Answer is minus 0.5.
So the first is 4 and the second is 13.5.
First is 4.
4 volts and second is 13.5.
Minus 13.5 is equal to, check it. Correct only, no? Minus 9.5. The field that I have taken is conservative. I will talk about it later. It says what? Hey, x squared by 2 is 4. Minus 3 by 2 y squared by 2, 9 minus 0. Because of which it is total, it is minus 9.5 volt. We see that two paths we took. The potential difference VBA is same for both the paths. Superficially, we can say that the field is conservative. Check it once.